I like to make analogies with kids. When we first learn angular momentum, I like to make analogies with linear momentum, which they understand. We sort of have an intuitive grasp for this. And also angular momentum, right? Sometimes, right? Okay, so the first thing I do is I say, okay, let's think about the momentum. Linear momentum, bullet strikes block of wood sitting still, right? This happens a lot in physics books, right? And the bullet strikes the block of wood. The bullet and block of wood move off, but they're going slower. And you know, you ask the kids why. Well, they've got more mass, right? Okay. So I'm going to take this wheel. I'm going to spin it up anti-clockwise. Let me step on the rotating platform. Right there it is going. It's going lickety-split anti-clockwise. I ask them, what's going to happen if I stop it? Right? Of course, I'm rotating anti-clockwise. Why am I not going as fast as the wheel? Well, yeah, I've got a smaller moment of inertia, right? Okay. The next one, the linear momentum, is you fire a rifle bullet, but you're standing on ice skates, right? You know, apparently people do that, right? And so, well, the bullet goes flying that way, right? And the person moves in a more stately manner the other way, right? So, okay, so what's going to happen if I stand on this and I spin this up anti-clockwise? Let's try it. This is going anti-clockwise, I'm going clockwise, right? So it's the same exact thing, right? Okay, and then I ask them, I go, okay, what if I do this though? This thing's going anti-clockwise. Can't I make it go clockwise by just turning it over? Maybe we can fool angular momentum, right? So let's try that, right? There it is, it's going anti-clockwise, so I'm going to turn it over. And sure enough, I'm going anti-clockwise, right? Lickety-split around the other way, right? Okay. And you can actually, if you figure out those precession forces as you're turning it over, you can see that there's a torque that's going to torque me anti-clockwise, right? Okay. And then you can do, okay. And the kids in Tualatin all understand if I pull my arms in, what's going to happen, right? Whoa. Because there are these gates at Ibach Park, right? Okay. So I decrease my moment of inertia. Is that going to get rid of the angular momentum? Or is it somehow conserved, right? You know, and then you can get into why you actually do go a little faster, right? And then I have the kids stand up on their toes, and you got to spread them out. They got to have room to flail their arms, right? Stand up on your toes, and try to lose your balance a little bit forward, right? Okay. And you're always going to wheel your arms this way, right? When you're trying to get your balance, if you're tipping forward, you're always going to wheel your arms so that they're going forward on the top. Well, that makes your body rotate backwards. And if the kids don't believe you, I say, okay, try doing this. Lose your balance forward and try rotating your arms the other way, right? Okay. And I suppose you could get on a balance beam and people would rotate their arms one way or the other, right? Depending on which way they're losing their balance, right? And then, the question is that nature or nurture? Did we learn that? Probably we do. I mean, probably it's a common experience to like, okay, this gives me balance this way, this gives me balance that way. But it's conservation of angular momentum, right? And then, I'll stand on the platform, right? Kind of like this one. Right, this is the same thing, right? I'm waving my arms around. And so in space, if I was floating in space, I could orient my body whichever way I wanted to. So then I show them videos of people cliff jumping, like more than 20 feet, right? And not the good people, not the people that can like tuck and do all kinds of crazy stuff. Like the idiots like me that are just gonna land on their feet with like, whoa, I'm jumping off a cliff, right? And what I notice is, and you can see this in videos, is that people are doing this, they're also doing this, right? And of course there's a strong incentive as you fall off that cliff. You don't want to go face, you don't want your face to rotate forward, that hurts. You don't want your back to rotate backwards, that hurts, right? And so these people are adjusting their orientation to the water by waving their arms, by using angular momentum. I bet they didn't learn that though. I bet maybe just come that way? I mean, I just don't know. Anyway, that's what I do with sort of intro to Angular